Hello everyone, welcome back. In this video, we will be covering all the topics related to Hive. Not all except for the queries, because the queries were too much, and I would like to show them in the laptop. Writing here it will be very hectic and time consuming. So we discussed about Hive in module 1 2, but we did not discuss it in detail. So now we will be looking into what is Hive. Okay, so in the module 4, we have to talk about Hive and in detail. So here everything is there about Hive. All you want to know. For you can also with the help of this video, I can say you that I can guarantee you that will be prepared for examinations. Okay, so we have all the headings are red. Red marker is nothing but chapter and its sub chapters like 9.1.1 like that and all till up to 9.4. Okay, so 9.5 and 6. Also 9.8 is all related to queries, all program type of thing. But anyways, let us start. What is Hive? Okay, so Hive is nothing but a data warehouse which sits above the Hadoop. So we have studied about Hadoop, right, and HDFS. If I have to tell more in detail, that it sits about Hadoop, not just Hadoop but above HDFS. Okay, so there will be a diagram in the architecture. I could not draw the diagram because I did not have the space, but I have written all the diagrams. So here will be, this is our Hive which sits above the HDFS. Okay, so HDFS basically consists of job tracker, task tracker, map reduce and all for receiving and managing the task. Anyways, so what Hive is actually made for, like purpose, summarization, querying and analysis. The building blocks of Hive. So what Hive is made up of? It building block in the sense, it's not like it doesn't consist that it takes help of it. Okay, so HDFS, it is connected with HDFS for storage. Okay, also map reduce function for execution, RDBMS for storing metadata. All these three doesn't come under Hive, but it is connected with Hive. Like you can see here, Hive is here. It will be communicating with them to storaging and execution. What Hive is and what Hive is not. Hive is for data warehousing application, suitable for data warehousing application. Is batch processing and for immutable data. So it does batch processing for immutable data, OLAP, online analytical processing. Example, web log and application log. So just remember the key points. From this you can explain extra from your own, but always remember to highlight these particular things. What Hive is not. Hive is not RDBMS. It is not suitable for online transaction processing, OLTP. It is not designed for real-time application. It is not designed for row-level data processing. Okay, row-level in the sense, same, right? Like SQL type, SQL, that is SQL. Okay, so history of Hive. Actually, in the textbook there is only a diagram about history of Hive, like Hive 1.1, 1.3, 1.4, like that. So and the only explanation for the history of Hive were 4 points each for all the three Hive levels. So I did not write here. You can just see it in the notes and understand. Hive features. Okay, Hive, the first feature is it's similar to SQL. Like SQL is a very rich query language, but it doesn't support many things. So that's why we are using HiveQL. So see, HiveQL is a query language used in Hive, and it is SQL is also a query language, but Hive is similar to SQL in the sense what HiveQL is similar to SQL, easy to code. So whoever knows SQL can easily code HiveQL because it's very similar. Rich data type, so it supports structure, lists, maps, and all. SQL operations, so it also supports the operations which are there under SQL, like creating the table, joining, all those multiple things. Then extensible in the sense what it allows you to create custom types and custom functions. Okay, Hive integration workflow. So here is a Hive integration workflow where log is distributed to Hive and then how it creates table. It's just one diagram in the textbook, and explanation is not required for that. So we'll move on to the Hive data units. So Hive data units, like what is the actual workflow or working of Hive, like how it distributes or divides its work and where it stores. So we have database, table, partitions, and buckets. Very interesting topic. Database is nothing but the namespace for the entire table, like in which multiple tables. So in easy understanding, I can say you that collection of multiple tables is nothing but Hive. It's all similar to SQL thing. Okay, so I have multiple types. If you have to take the example of MongoDB, I have multiple collections, right? If I store them all together, what do I call? I call it a database. So like that here, collection of tables together in table as called as database. It is a namespace given for tables. What is table? It is a collection of rows and columns, fields, records and all stored as a table. Okay, so that's table. Similar to SQL. Partitioning and bucket. Partition and bucket is very similar. So in the previous concept we heard about partitioning, that is in Hadoop itself, like, but here it's different. In the previous partitioning, what we had, we have suppose 30 kg bag will divide into 10 10 10, so that it reduces the seek time and all. But here it's not like that, like randomly you're just dividing the weight equally. It's not like that. Here you are partitioning, segregating based on criteria. For best example is, suppose the rice and some other grains got mixed, the dals and all, you will based on criteria. So this is same you divide it based on that, right? So here best example they give is like multiple, a company which is spread all over the world, and multiple countries are logging. So how do you divide user based on country? Like partitioning based on countries. So you are dividing based on country, that is partitioning. Okay. Bucket is also similar to partitioning, but here we use particular hash function or hash key value to segregate and store in column wise. So bucket shows us columns. Okay, column type, it shows us column types, and partitioning nothing but subdirectory. If you have a directory, like I said, complete all over the world map countries, and subdirectory is nothing but one country users are listed. Okay, that is subdirectory. Buckets like column type is stored. There also you have to write about partition versus bucket and one example like that. You can just look into the notes and understand that. Hive architecture. So like I said, let me just use space. If I have to draw like this, simple, you just have to draw these blocks like this, how I am doing. Okay, this is our Hive, and here is our HDFS, job tracker, task tracker and map reduce. Okay, just remember it's like that. You can see that in my notes. Okay, that's not a problem. So first thing is user interface. So here we have three things lined up together, that is command line interface, web interface and Hive server. Okay, so what does this three do? Command line interface is like direct terminal access to the Hive, like where you can do querying. The way we have Windows PowerShell, right, where I did the MongoDB query and all, direct terminal type interface. It's like terminal interface, so where you will be directly accessing the terminal. Web interface is like graphical user interface, common for most of the users. It allows you to interact Hive with a graphical user interface. Hive server. Okay, so some people they cannot actually access the interface directly. So if you want to submit Hive queries remotely, it can be done using Hive server. It supports the remote sending queries remotely. Then JDBC and ODBC. So it allows us to use the Java code. Okay, so the Java coding in that, and with the help of that we can submit Hive jobs using Java code. So basically Java cannot be used directly used, but with the help of this component we can use Java, and that Java codes are used to submit Hive queries. Okay, or Hive logs. You can just check in the notes, it's very small. After the interfaces is done, we have other three things, that is driver, metastore and execution layer. Driver is nothing but you had all this interface, right? It's like taking input. We are user, I'm doing the querying, that you are taking input. So those inputs are taken by driver, and driver what it does, it handles the compilation of that input, optimization and execution planning. It does not execute, it plans the execution and then sends to the HDFS. Okay, where job tracker tasks are there, and they'll do all the execution. Metastore is nothing but the database type of thing. It's like it stores all the tables, transactions, all the details and all. It consists of two components, that is a Metastore service and database. Metastore service nothing but providing an interface to the Hive. Database nothing but which stores all the tables and records and all stuff. Execution layer, you have job tracker, task tracker, HDFS, Hadoop cluster. So basically one particular cluster. So there are multiple clusters. Each cluster has this HDFS component, right? So that's a see, this is the HDFS, job tracker, task tracker. Also map reduce you have to write in that. Anyways, that's done. Then we'll talk about type of Metastore. We heard about Metastore, right? So there are three types of Metastore. That is one is embedded, another is local, and third one is remote. Okay, so for all the three Metastore, you just have to remember driver, Metastore, MySQL or Derby, both are same, but Derby is only for the first embedded Metastore, and MySQL for the remaining. Then Hive service, JVM, this is Java virtual machine. VM is a virtual machine. So first embedded, the diagram is like this. So here will be our driver. Okay, I'll just write D, and here will be our Metastore, and then directly to what to say HDFS. This is called Derby, and this thing is nothing but Hive server JVM. So the virtual machine, under the virtual machine itself, you have this driver, Metastore, and Derby. Talking about local Metastore, I'll just explain you the diagram in such a way that you can use the diagram itself as to explain in the examination. There are one or two words you have to look into the notes which I'll be providing in the description. So here you can see there are two different virtual machines. Hive service virtual machine itself, Hive service JVM. See, Hive service JVM. So now what is happening? MySQL, that is the database. Okay, so MySQL is separate from the Java virtual machine. Okay, so different virtual machines can store data. So like multiple users can be allowed over here. So here one user, all the data from other users are being stored in MySQL. So here driver Metastore. Each Java virtual machine is having a driver and a Metastore. Okay. Talking about last, that is remote Metastore. Here driver is having its own virtual machine. Metastore is having its own virtual machine. So separate virtual machine for each everything now. Okay. Driver is having Hive service Java virtual machine, and Metastore is having Metastore service Java virtual machine. Okay. So here is a driver, here is a driver, two separate. Okay. So here he will interact with this also, he will interact with this also. He'll interact with this, he'll interact with this. So what is happening? The driver Java virtual machine can interact with different Metastore Java virtual machines as well. And these different virtual machines will be submitting the data to MySQL, that is nothing but database. You understood, right? It's just like that. After you finish this, you have to move to Hive data types, that is primitive and collections. Under this there are particular data, very small, like from the beginning. That's mentioned in the notes. You don't have to worry about that. If you just look into that once, you will easily list it with an example. Then last 9.4, you have Java Hive file formats. There are three types of file formats. What is text? It's more like line wise, text in one line type of thing storing. Then sequential storing in binary form. RC file record column, in the sense you will be storing them one by one columns. So if you have a table 1, 2, 3, 4, 5, 7 like that, column wise, one column finishes, then second column. So this is all the explanation we require for Hive. Okay, so I have covered all the topics, I have explained all the topics, I have not missed anything. Whichever I did not explain, I have told you what is what, and that will be provided in the notes. I hope you like the explanation. Kindly do subscribe and give a like, because I deserve it, bro. Like, it will be very helpful for me if you like, and kindly comment if there is anything which you want me to correct, rectify, or explain properly. We'll look into that and do it in the next video.